Let us learn and enjoy. Our lesson for today is about logarithmic equations.
What you need to know. At the end of the lesson, the learners will be able to solve logarithmic equations. Let us recall changing logarithmic to exponential form. We can illustrate the notation of logarithms as logarithm base b of c is equal to a. This means that b raised to a is equal to c. Another, logarithm base b of x is equal to y. This is equivalent to b raised to y is equal to x, where b should be greater than 0 and b should not be equal to 1. Logarithmic equation is an equation involving logarithms. Let us also recall the laws of logarithm. Number 1, logarithm of a product. The logarithm of a product is equal to the sum of the logarithm of its factors. Logarithm base b of xy is equal to logarithm base b of x plus logarithm base b of y. Example, logarithm base 2 of 3x is equal to logarithm base 2 of 3 plus logarithm base 2 of x. Number 2, logarithm of a quotient. The logarithm of a quotient is equal to the logarithm of the numerator minus the logarithm of the denominator. Logarithm base b of x over y is equal to the logarithm base b of x minus the logarithm base b of y. Example, logarithm base 3 of 4 over 5 is equal to logarithm base 3 of 4 minus logarithm base 3 of 5. Number 3, logarithm of a power. The logarithm of a power x raised to n is equal to the product of the exponent n and the logarithm base b of x. Example, logarithm base 5 of 6 squared is equal to 2 logarithm base 5 of 6. Let us now solve the following logarithmic equations. Number 1, logarithm base x of 27 is equal to 3. First, let us change the logarithmic equation to exponential form. So this will become x cubed is equal to 27. Get the cube root of each side of the equation to find the value of x. So we have x is equal to 3. Number 2, logarithm base 2 of x is equal to 5. Let us change the logarithmic equation to exponential form. So we have 2 raised to 5 is equal to x. We all know that 2 raised to 5 is equal to 32. So x is equal to 32. Number 3, logarithm base 3 of 243 is equal to x. Let us first change the logarithmic equation to exponential form. So we have 3 raised to x is equal to 243. Next, change 243 as 3 raised to 5 so that each side will have the same base. 3 raised to x will be equal to 3 raised to 5. Since the bases are the same, then we equate the exponents. So x will be equal to 5. Number 4, logarithm base 2 of x plus 5 is equal to 3. Change logarithmic equation to exponential form first. 2 cubed is equal to x plus 5. We all know that 2 raised to 3 or 2 cubed is equal to 8. So we will replace 2 cubed to 8. So we have 8 is equal to x plus 5. To find the value of x, let us add negative 5 to each side. So x will be equal to positive 3. Number 5, logarithm base 3 of 2x minus 3 is equal to 2. Change logarithmic equation to exponential form. 3 squared is equal to 2x minus 3. We know that 3 squared or 3 raised to 2 is equal to 9. So we have to replace 3 squared to 9. 9 is equal to 2x minus 3. To solve for x, let us first add positive 3 to both sides of the equation. So this will become 12 is equal to 2x. To find the value of x, let us multiply both sides of the equation by 1/2. X now is equal to 6. Number 6, logarithm base 2 of x minus 3 plus logarithm base 2 of x minus 1 is equal to 3. Let us first apply logarithm of a product. Remember that the logarithm of a product is equal to the sum of the logarithm of its factors. So this one will become logarithm base 2 of x minus 3 times x minus 1 is equal to 3. Next, let us change the logarithmic equation to exponential form. 2 cubed is equal to the product of x minus 3 and x minus 1. We know that 2 cubed is equal to 8. Then, multiply the two binomials using FOIL method. X squared minus 4x plus 3. Next, add negative 8 to both sides of the equation. So this will become 0 is equal to x squared minus 4x minus 5. Factor out x squared minus 4x minus 5. The factors are x minus 5 and x plus 1. Let us solve for x. So we have x is equal to 5 and x is equal to negative 1. Let us substitute negative 1 to the given logarithmic equation. So we have logarithm base 2 of negative 4 plus logarithm base 2 of negative 2 is equal to 3. Take note that you cannot have negative log. So therefore, the answer is x is equal to 5. Number 7, natural logarithm of x is equal to 7. This is also equal to natural logarithm base e of x is equal to 7. Change this to exponential form. So we will have e raised to 7 is equal to x. And the approximate value of e raised to 7 is 1096.63. Number 8, logarithm base 2 of x squared plus 4x is equal to logarithm base 2 of 5. Take note that if logarithm base b of m is equal to logarithm base b of n, then m is equal to n. So applying this, we have x squared plus 4x is equal to 5. Add negative 5 to each side. So this will become x squared plus 4x minus 5 is equal to 0. Factor out x squared plus 4x minus 5 is equal to 0. The factors are x plus 5 and x minus 1. Let us solve for x. So we have x is equal to negative 5 and x is equal to positive 1. What you need to remember: changing logarithmic to exponential form, we can illustrate the notation of the logarithm as logarithm base b of c is equal to a. This means that b raised to a is equal to c. Another, logarithm base b of x is equal to y. This is equivalent to b raised to y is equal to x, where b is greater than 0 and b is not equal to 1. Logarithmic equation is an equation involving logarithms. Also, we have to take note of the laws of logarithm. Number 1, logarithm of a product. Number 2, logarithm of a quotient. And lastly, logarithm of a power.
Thank you everyone for watching this video. Truly, learning mathematics is fun. See you in our next video. Have a good day!